Okay, so that is how Crusoe can choose whether to buy a product or not. But how will he choose how to fill up his shopping cart, his full bundle of goods? When he has to buy combos of products, right, things get a bit confusing. That is when we have to use total utility or TU, the total satisfaction he can get for all the money that he is spending. Being a rational individual, we assume that he wants to maximize the TU he can get inside that shopping cart. That's all that matters. How to spend the money he has so as to get the maximum TU possible. That is the question for Crusoe. And this is called consumer choice, this final purchase bundle choice. To answer this problem, we need more graphs. Again, we're going to simplify the world to build a model. Let's change this supermarket around Crusoe so that there are only two products available, milk and eggs only now. We will denote this by a notation, right? We'll use X1, X2. X1 will be the amount of product 1 in basket and X2 for amount of product 2 in basket. For us, product 1 will be milk and product 2 will be eggs. So if Crusoe takes 3 milk bottles and 2 eggs, how do we denote it? We denote it as 3, 2 inside brackets. Let's observe his rational behavior now. First, you should understand there is a large variety of ways in which Crusoe can fill his shopping basket. He can take 0, 0, he can take 1, 1, he can take 3 milk, 4 eggs, and so on. These bundles are his options now. He has to choose from among them, right? Now, do you remember the earlier assumption? Crusoe can easily compare and rank all the possible bundles so that he can choose between them. So, given any two bundles or sets, either he will like one more than the other, or he might feel the two bundles are same for him. That is, if one bundle is substituted by another, he doesn't really feel a change in his total satisfaction or utility. Basically, it wouldn't make a difference to Crusoe in such case. A technical term here for us, in economics, in such cases where he likes both the bundles the same, we say the consumer is indifferent between such bundles. Like this, we can list out all bundles in the order in which Crusoe likes them. Some bundles he might like more than others, some he might not like as much as others, and some he might be indifferent between. To denote how much he likes each, we can give utility numbers to milk and eggs. And we can also add the total utilities or TUs to our bundles. This will represent how much satisfaction Crusoe gets from purchasing each bundle. So, if he likes a bundle more than another, it would mean the TU of that bundle is more than the other one. If he's indifferent between two bundles, that would mean the TUs are the same. Every time we make a box like this, we end up drawing a graph from it, as you might have noticed by now. And you're correct. The points representing all the bundles which are considered indifferent by the consumer can be joined up to get a curve. Technical term again, such a curve would be called an indifference curve. Let's draw an indifference curve and let's see how it looks like. In fact, for each ranking in the box, we'll have a separate indifference curve, as we will see. So let's draw an indifference curve and let's see what it looks like, right? So what we're going to do is, we will have the y-axis here and the x-axis here. The x-axis is going to represent the number of milk bottles that Crusoe can purchase. And the y-axis will represent the number of eggs. And any point inside the graph will represent a combo of products. So each point will represent one combination of products. Now in the box here, again, all these combos are listed out and ranked accordingly. What we're going to do is, we're going to take those points and plot them on this graph here. Once we have plotted, we can actually draw an indifference curve for each of those points. So you can see here, an indifference curve has come for each of those points. And the top ranked point on the box will become the top ranked indifference curve here, or the highest indifference curve. And the bottom ranked point on the box will become the lowest indifference curve here. In fact, for each ranking on the box, we'll have a separate indifference curve. And on each indifference curve, we can see if we move along the indifference curve, right, the TU remains a constant. That is one of the properties of an indifference curve. By the way, don't this whole curve and graph and everything look like what we saw earlier with Crusoe on the island? Anyway, we did not make Crusoe sad by thinking about those bad times. Now we are back in civilization. Let us stick to the supermarket for now. Let's go back to a graph now, but this time we'll have only one indifference curve on it. Let's remove all the other indifference curve. And let's keep the graph on this side, right? Now take any point above it. Take any point above the indifference curve. We can see that such a point has more of either milk or eggs as compared to points on the indifference curve below. Any point above the IC is considered superior to the IC. That is, Crusoe will always choose that bundle over any bundle in the first IC. Why is this so? Because any such point will give Crusoe more TU, correct? So he prefers such points over any on a lower IC. Now we know there will be another IC passing through that point. All points on the second IC will have a TU higher than the first IC. Same way, any point or bundle below the curve is considered inferior and will have a TU less than the earlier IC. Now we are going to represent this in a different way from now onwards. We are going to show it like this.
Hey, where did the TU numbers go and why are there smileys on the graph?
Yes, correct. We have changed the numbers to smileys now. So here the thing is that utility can be represented in two ways, cardinal and ordinal. Until now, we were showing cardinal utility values. We used to show the actual numbers. But in fact, it's easier to rank them instead of showing actual numbers. And it serves a purpose too. So smileys here just represent how Crusoe ranks these ICs. More smileys would mean Crusoe's more happy with all the bundles on that IC. Same thing, different representation. I hope your doubt is clear now. Let's add another IC to the graph here. Let's say it passes through a higher point. Like this, we can keep on adding ICs. And we can have a number of indifference curves. This full series of indifference curve will be called an indifference map. Now it's assumed that consumers like to be on the highest IC possible. So higher the better. They want to go as high as possible here. This is called monotonicity of preferences. Don't get scared. It looks like a big word, but monotonicity of preferences only means that between any two given indifference curves, right? The bundles on whichever lies above are preferred to the bundles on whichever lies below. Simple? What this means for Crusoe is that if he is given two bundles to choose from, he will always choose the one which has more of at least one of the goods, that is on a higher IC. Let's take a couple of examples to understand this. Consider 2,2 bundle here. This bundle has more of both goods compared to 1,1. It has equal amount of milk but more of eggs compared to 2,1. But compared to 1,2, it has more of milk and equal amount of eggs. If Crusoe has monotonic preferences, he would prefer the bundle 2,2 to all the other three bundles 1,1, 2,1 and 1,2. Here are a few more examples bundles for you. Try to figure out which one Crusoe would like in each case based on the monotonicity principle. If you're confident that you understood monotonicity from these examples, try to answer this question. Take two bundles or shopping carts. You can see that one bundle has more of milk than the other bundle, 3 in one and 2 in the other. Now, if I tell you that for Crusoe, these two bundles are indifferent, what can you tell me about the amount of eggs in each? The answer would be that since the consumer's preferences are monotonic, these two bundles can be indifferent only if bundle A having more milk has lesser eggs as compared to the other bundle.